Yeah. 1125, smallest sufficient team. In a project, you have a list of required skills, work skills, and a list of people. List of people. Why did see? This is not consistent. They just. I mean, okay. It's not a big deal. I'm ranting. The I person is people sub I contains a list of skills that person has. Consider a sufficient team. A set of people such that every required skill in work skills, there's at least one person in the team who has that skill. We can represent these teams by the index of each person. For example, team equals 0, 1, 3 represent people with skills, people sub 1, people sub 0, people sub 1, people sub 3. Return any sufficient team of the smallest possible size represent by the index of each person. You may return the answer in any order. It is guaranteed that answer exists. Okay. So required skills. I read a lot of stuff, but let me double check that. Let me read the examples to see. I don't think I understand. I just read a lot of stuff. Cool. That's the problem with me sometimes. I read things aloud and I'm not actually reading it because I don't read that aloud the order that I read it, because sometimes I read the same sentence like 5 times before I move on to the next one. So maybe it's a bad habit. I don't know. Tell me what you think about it. Okay, I set up every. So let's say what? Oh, so basically, if I have Java and React, these are the required skills. Having the Java person and the no React JS person will give us both. Okay. So the next thing I'm looking at is kind of. So this is like almost like a, I forget which one it is. Either edge cover or vertex cover. I'm really bad and confused. But well, let's look at the constraints. Where okay, so the number of skills is 16. People length. So there could be 60 people. What does that mean? Oops. Okay, I mean, and each one of them contains skills that are within that length, which is fine. I mean, yeah. Also, probably not C. Let's see what happens. Okay, they're distinct. I should have used the bathroom before this. Mistakes were made. It's fine. Now I have a running clock, if you will. But okay, they're all English. Every skill has a skill and requires skill. It is guaranteed that a sufficient team exists. Okay. What do I think about this? Well, my first observation is that the required skill set is 16. What that means is that if you represent, so you could represent it in a bit set. So that's an optimization that I'm thinking about just off the bat, and because I don't know if that means anything a bit set, but 2 to the 16 is like 32,000 or something like that, right? And yeah, you could just do a bit set, and which means you could represent the set of skills as one number instead of, maybe as a set. So what that means is, what does that mean? So what that means is just it's more efficient in maybe some operations that we can do. And also the other thing with bit set is that you can do bitwise OR, which is a much cheaper operation than, if you have a set and then you do an OR, which, for example, in Python or something like that, right? So, okay. And the number of people is 60, which is fine. I mean, so the number of people being 60 means that, what does it mean? Which means you cannot do a 2 to the n type thing because, well, 2 to the 60 is, I don't know. I mean, it's ginormous, is what I'm saying. But I think I'm going to use C++ on this one for a reason I'll show in a bit, because of lower bounds, maybe. Do I? Maybe? I don't know. But there's a... So the problem that I'm thinking of, so these are, I mean, there are more constraints, but they're just like clarification constraints. I don't think it matters that much. I mean, given these two constraints, I think the problem that I am reminded of is what do they call it? Something in the middle. I forget these algorithms' name. It's been a while, but it's something that's used for. If you ever know traveling salesperson problem, TSP, which is a very well-known comp sci problem, right? And you could solve it with 2 to the n, but there actually is a solution that is, I want to say n times 2 to the n over 2, which is, I forget what it's called, like merge in the middle or something like that. I forget the exact name, so maybe someone could Google it, or like, and then we'll send a link or something. I mean, I know what it is, so I don't have to like Google it. But if you're interested in learning more about it, that's how I would kind of search for it in a bit. But that also means is that it should be good enough for this problem. Maybe. Do I have to go through all of them? So let me think for a second. Well, to the because the thing is noting that because there are only 2 to the 16 possible skills, so given 2 to the 30 is a little high though, isn't it? I think what was 2 to no, yeah, I mean 2 to 30 is like a billion, right? Is that fast enough? Is there a dynamic programming solution? Oh yeah, maybe there is. Wait, what am I finding? Oh, the smallest size. Yeah, maybe there. Maybe there's just a dynamic programming. Maybe I'm thinking of something else. I feel like if this is smaller a little bit, then we could actually just do what I just said, which actually comes up randomly sometimes, but not that often. Maybe. Maybe I'm thinking of something similar, but what is the dynamic solution? The dynamic solution is your your dimensions are 2 to 16 times 60, maybe something like that. For the I person, how many people do you need to reach a certain set? Yeah, 60 times 2 to the 16 should be okay, if that is how I do it. Huh. So this is the harder dynamic program problem then maybe. I think if this was 40, then I would do what I said about meeting in the middle. Because 2 to the 30 is a little on the edge. But 2 to 16 is pretty, like I said, it's just 32,000, so. Okay. So basically, I don't know if I'm still using, maybe I'll use C. And then the second part is kind of reconstructing the output, which is also not easy, but not hard, so it should be okay. But basically, what I want to construct is you have f of the index I, and then some set, right, which contains kind of the set of required skills that we match. So yeah, so that is just equal to I minus 1, another set. That's I don't know why. Where basically it is just if you add this to the set of skills, what is the minimal to reach that set? Yeah. Okay. Let me just write down the definition first. This is the minimal to reach sets of X with the first I people. Yeah, and then you could kind of recursively solve it by going to F sub, I minus 1, and then set sub, I don't know, X minus 1 maybe. Or, the OR of the skill set of the I minus 1 person. My syntax here is a little weird, but something like that, right? So in theory, that's okay, but then you have to do it over OR of 2 of 16. Is that too slow? No, because, yeah, maybe. Because then now you have 2 to the 32 type thing. Because if you have to iterate through all of it, maybe that's where I need binary search, maybe? Let me see. Can we just do half? Yeah, I think, I guess in a very long and roundabout way, maybe we did need that weird meeting in the middle thing. Because I'm thinking of something like this, but then this is for all sets of what? Like all subset of set of X or something like that, right? Whereas in the cardinality or the size of the set of X is you got the 2 to the 16 up to, which means this kind of complexity would be 2 to the 32, right? Which is 2 billion or well 4 billion technically, which is way too high. But if we divide it into half, let's just say we have two problems where you have, let's say, the first 8 skill set, right? And then that means you have 2 to the 16. So now your running time for that is 2 to the 16, but then you have 2 of them. So then you have 2 times 2 to the 16. But then now you have to merge them. How would you merge them? I mean, this is fast enough, but you can't just do, like 2 for loops, because then it's 2 to the 16 times 2 to the 16. So maybe there's some like subset type bit things. I think I'm on the right track. I just missing one thing which bridges the gap. Because now you have 2 arrays. What does that mean too? Can naively, but well, there's only 8 bits, so given no, what am I saying? No, but that I think so. What I'm thinking now is, let's say we have a min for a subset of it. Is it sufficient to? Because I think it's slightly more complicated in that, the set addition is more so you may have 2 numbers that are bigger than the minimum for the components, but then when you merge them, because of the set addition, they may just encompasses, may have a smaller set addition. But on the other hand, if we keep track of everything, there's 2 to 60 possibilities, so that's kind of high too. Huh. Here's a hard problem. Probably not. Can we merge 2 sets? No, not really. The main of no, you definitely cannot, because not easily, because you definitely have a case where, for example, one person satisfies all the skills, but you break it into 2 sets, then sometimes you have 2 different people, and then you add them together, and that would just be awkward. Can we separate them into teams so that they're non-intersecting? No, that doesn't make sense, does it? Do I have to do it for all subset? Maybe this isn't as hard as I thought. Maybe I'm just doing it weird. Yeah, maybe I'm just confusing myself. Let me try to code this up, and then let me try to code this up, and then let me see if I can figure out some patterns. I'm going to use C++ actually. Just because in general I'm more comfortable with playing with bits in C++ versus Python, which maybe I shouldn't be, but okay, cool. Okay, and so I first have to parse everything into a thing. Yeah, maybe I have to Python. YOLO, learn something new today. Okay. Okay, people. Okay, cool. Skills to number. The other way. Okay. Otherwise, that doesn't seem necessary. People. Oh. For skill and call. Alright, just person. Okay, skill and person. Mask. Yes. Then skill. title, and then we left shift this. Okay, and then let's print it out just to see if I'm on the right whatever. There should be 0 or 1 or something. Oh, well, I guess I should add it to the array. That would make it easier to print it out. But there should be 0, 1, and then 6 or something. Okay, yep. Okay, so that's how we convert it to masks. Okay, let's solve the problem then. The easy part, right? Okay. Calculate, and then we start the first person, and our mask is currently 0. But I have to do something else, which is number of scale. That's okay. Actually, I guess I just do this, and also the number of skills. Okay. People index and mask. Okay. If mask is equal to is it one return well just return 0. Oh yeah, I have to reconstruct it. I can't just print it out. Or I can just return the minimum. But I'll get the numeric answer first, and then I'll work on kind of figure out how to do the reconstruction, which is not that bad. Okay, so now we just return best is equal to, say, I guess just like 100, because it could be 60 or whatever. Probably would be the best answer, or the default answer. So, oh yeah, see if it's in cache. If index mask in cache. Maybe I like that. Okay. And the main is so there are 2 ways to do it. We saw 1 is equal to this index is equal to mask. That means it's not fulfilled. Okay. So this is the case where we don't use this one. So it's smaller than best. And then we saw 2 is if this is equal to, and we do use this one. Maybe I confused myself earlier with all that talk. And then again. Maybe this is enough. Let's see. This will not return the answer, but stop that calculate. Or it will not return the complete answer. It will return just a partial. Oh man, that's what I always forget about Python 35. Oh, I did this another place. Yeah, I just didn't save or something. Did it press the button too quickly? Oh no. Hmm. Oh, that's no good. Am I? Oh, yeah. Eh. I think should only the largest stack depth should only be 60 for people index, so it should be okay. Oh, well, thanks for checking. I was just kind of, yeah. Okay, fine, let's put it away. I just wanted to sanity test myself. I know that this is not the right answer, but 0 is probably not right. I have a weird default thing. Oh, well, oh, because I don't add this. So this is me using 1, so this is this plus 1. Okay, oops. So ideally this would return 2. Okay, we also just test the other one real quick, because if it's wrong then that get out of the way quickly. Oh, what am I doing? Oh, what? Oh, are these two different? Oh no, I have to. Okay, I'm just really bad at copy pasting. Okay. Okay, still 2. I think one more thing I want to test is the running time if I have a lot of skills, which is something that maybe I worried excessively unnecessarily, but I did a lot of analysis, but maybe I was wrong for, because I thought I had to iterate through all the masks, but now that I coded, I guess I didn't. I don't know why I thought it that way. But okay, was it 1, 2, 3, 4, 5, 6? I just create. I never have to get the skill to one person at least. That still went pretty quickly, right? Am I confident about this? Okay, maybe I am. Okay, so now we have kind of the answer. Why did I think I don't know why I said, maybe this part kind of confused me off, or subset part, which I allow my analysis to be right, but or to be crazy. Yeah, I don't know why I thought that. Other than I don't know. Yeah, well, no point in dwelling in it. So okay, so now I think I go over this in another problem. So now we have to do what is called path reconstruction, and for more in depth of that, I think I generally they'll use the examples to kind of demonstrate it more. So I recommend just YouTubing it because nowadays they're really, they're really cool about it. I'm really like impressed in general. But that's what I'm going to start trying to do. Okay. I have this, I guess, for impossible situations, which, okay, that's fair. You want to, yeah, I mean, that's right. A little awkward. Is this right? Let me think. Yeah, Guess so. Okay. Now, let's say we can solve that reconstruct. I guess that's fine. Index. And you could return the ends in any order, okay. So, okay, if maybe I should add one more thing to this, just to make it similar to this tuple, though I think, as people have pointed out in the past, I should use a name tuple for this. But yeah, if, okay. So now if you go to, if mask is equal to, return else. I don't know if that's the way I want to do it, but maybe that's fine. Now, because I don't want to, I want to take advantage of some stuff instead of printing all possible answers, or not, instead of kind of do some n square array construction thing. I want to just keep it n. So, okay. Let's go to. Okay. If now the second to the one, then we do we do answer that append this people index, because that's the one where we add, and then yeah, that's probably good enough. Otherwise, we actually could probably do this with a while loop now that I think about it, but yeah, it's fine. It's not that deep. And then now we construct on oh. Did I not cache everything? Oh, no, this is, okay, I do things in a weird way, but okay. What do I do this way? Why isn't that what we start with? Oh, wait, did I delete the calculate function? Huh, I guess I did. Whoops. Because I renamed it, or I took it out to return. Oh, a lot of silliness. We're so close, but either we're so far or not, we'll see. Oh, and I forgot to call self, and oh, I do. I don't have to return it, right? Okay. Oh, yeah, oops. This is not a tuple. Okay. Am I happy with this? Yeah, okay, YOLO. I should have tested at least the empty cases and stuff like this. I'm usually good about it. Oh, well. Okay, cool. Uh, how do I feel about this? Okay, well, post-mortem first. I think one is, I don't know why, but I guess for whatever reason, look at the constraints, which sometimes happens. Like, I guess even what I was talking about last problem, sometimes you just don't think about the clearest answer ahead of time. And I got stuck a little bit on what, the merge in the middle type, TSP type thing. So you skip all that. But apparently the recurrence is much simpler. And it's something that I guess I definitely thought about it even earlier on, but for some reason my analysis of it was bad. I wasn't thinking about it clearly. I thought you had to do some kind of construct all possible set. And actually, this is one. There's maybe one example where memorization is way more effective than dynamic programming. Can I say that? Because is that even true? Maybe not. Maybe I take it back actually. Uh, but this is, I mean, it's definitely slightly more efficient because there's some unreachable states. But I would maybe that doesn't matter enough. Maybe I take that back. But definitely for whatever reason, my analysis was it that it was yeah, like I had some n square in there that wasn't n square. The 2 to the 16 square would have been 2 to the 32, which is too high, which is definitely still true. But it ended up that my code did not need to. It just did two operations, and I would have to kind of go back to the one thing that I do when I try to learn is, especially from my mistakes, even if I got it right eventually and try to fix, you can still make improvements on timing and stuff like this. And I would have to go back to the real tape, which is one benefit of streaming and taping, is kind of see what my thought process is and why I kind of got stuck in that loop, because this is only two operation. So it's not, it shouldn't be, and you don't need the entire, so it's 60 times 2 to the 16 times, that's the space, and the time is just times 2 because you only do two operations at each point at most. So that should be the correct analysis. Maybe I just kind of, I don't know, I was just drawing the graph a little bit weird in my head and I kind of got that wrong. But which happens, but I want to see, I will go back to the videotape, if you will. It's not, maybe people don't know what a tape is anymore, but go back to the cassette tapes to see what my thought process is. So that's something that I will definitely do later. But that aside, I think I don't know how I like about. I generally don't like stuff that requires bitwise optimization for an interview. I mean, as a brain teaser problem, this is fine. I mean, it's part of the things that you're learning and you're going to learn, and it just become part of your skill set. But for an interview, it's not what I like to do because, like, I don't know, bit set is something that maybe even, especially nowadays, there are abstractions for it. Like I think in C sharp, like you could do like enum things and bit set or you could do sets in C sharp or maybe even Go. I don't remember, to be honest. It's been a bit, but where like they do the optimization for you to compile it into using bits so that you get that efficiency of a lot bits without dealing with kind of crazy sized sets and so forth. Where I don't know, Python, for example. I mean, there probably is the library for it because there's a Python library of everything. But if you use the built-in set, well, these operations will get kind of expensive, especially if you pass it around, you cache based on the set and stuff like that, or doing your memorization for a set and something like that. But yeah, for that reason, I don't necessarily like that part of it for an interview problem. But difficulty is maybe okay. It's just doing an exhaustive search in a weird way, knowing kind of your size, the constraints based on your set size and stuff like that. But it's still probably a little bit more difficult than I would expect on an interview. But yeah, but overall, I think I don't know, it is tricky to talk about dynamic programming problems for me in general because sometimes it's either you see it and it's really easy, and when you don't, it's like, man, you really don't. And it takes a little bit to kind of like, so this time I got a little lucky in that regard. Um, so yeah, so I'm happy about that. I have to explain some of. I don't think I explained it that well, but basically, my explanation of this problem is that n is 16. So for n is equal to 16, it's just you have n being the number of skills is 16, meaning there's only 16 possibilities, or 2 to 16 possibilities. Sorry, you know that composers of the thing, right? So you could kind of take advantage of that by and the number of people is 60. So your other dimension is whether uh, uh, you know the minimal to reach set X with the first I person, right? So that's kind of how you construct it. And then at the end, you want the set to be, all the numbers, and you don't have to use all the people, but we kind of transparently or whatever, transitively pass it along anyway. And then the second part of this problem, so that's the DP part of it. The memorization is how I implemented it. But the second part is the reconstruction of the path, which is something that I'm not going to go too deeply into it. But it's just a way to kind of back calculate how what's the best from this point, and then you kind of go for, keep track of it, and then print it out in a way that starting from scratch and so forth. So that's kind of how the algorithm works. For more of that, I definitely recommend just Google or YouTube path reconstruction and dynamic programming. They have easier examples because the problems we solve here are generally like more complicated, but it goes through all of it. The distinction is mostly that, like, for example, what's the example I used the other day? But let's say you have a problem, and like for example, even for this problem, right? Like, you could do the dynamic program to calculate what's the minimum people that you need to fulfill all these fulfill these skill set. But if you want to know exactly whom to use, then that's what the path reconstruction is good for. So yeah, in general, this problem is a little hard. I don't think I would ask this in an interview problem. I think the other part is that if I was interviewing someone and they get stuck on this problem, I don't necessarily know how I would kind of give them hints, maybe kind of nudge them about the constraints. But at that point, it's like a very specialized type of kind of algorithm for a specific problem. I like to ask more general problems, either maybe graphy or dynamics, binary search or so forth. And in terms of cleaning up the code, there are a couple of few things that I kind of could do a little bit better with the code cleanup, for sure. Well, first of all this kind of stuff is all over the place. I could definitely have more helpers. For example, I don't like converting the people skill to a bit mask. That's something that should be abstracted a little bit. And yeah, stuff like that. And maybe the variable names could be better. I also definitely do not what do you call it? Like I didn't want to do some weird passing in a way around and doing some possibly n squared constructions. I do some optimization here and there on what maybe is considered like global variable type things. Well, in this case, it's class variables. But so like I pass those along, though in theory, you could pass them into the function and put them on stack trays or whatever, or stack and so forth. But otherwise, I mean, these are definitely things I could do better, and maybe renaming some variables. They're not super intuitive, but yeah. But overall, I'm relatively happy with it. I think I spent a little bit longer than I would like, just getting stuck a little bit mentally. But maybe that's something that like I said, I'm gonna go back and review what I did. Cool.